Alright, great. In the previous lectures, we wrote a function to calculate weight of evidence for any discrete independent variable with respect to an outcome variable. We also wrote a function to visualize how weight of evidence changes across the categories of the independent variable. It took us a lot of time, but these efforts will pay off, I promise you. Now, let's apply these functions to calculate and visualize weight of evidence for all discrete variables we've decided to use in the probability of default model. Based on weight of evidence, we must decide how to organize the original categories of the discrete variables into dummy variables for the PD model. We've already calculated and visualized weights of evidence for the categories of the grade variable. Remember that the grade variable reflects external credit ratings. Of all variables, it's the one that should have very good patterns on weights of evidence. Indeed, as you can see on the chart, weight of evidence increases almost monotonously with the increase of external credit rating grades from the worst G to the best A. The greater the grade, the greater the weight of evidence. That means loans with greater external rating are better on average. Based on this pattern of weight of evidence, let's keep the original 7 categories of the grade variable as independent variables for the PD model. Let's keep a record of all the dummy variables in a spreadsheet. We'll call it List of Dummy Variables. So the first 7 dummy variables will be the variables from grade (A) to grade (G). When we put these dummy variables into a regression model, we should keep one out as a reference category, the category against which the impact of all others on the outcome will be assessed. At this stage, it's a good idea to keep a record of which dummy variable will be a reference category when we create all dummy variables for each original variable. Let's establish that we'll always keep the category with the worst credit risk as a reference category. That is, the dummy variable that has or is composed of several categories that have the lowest weight of evidence. Let's keep a record of these reference categories in a spreadsheet. We'll call it List of Reference Categories. So grade (G) will be the first item in our list of reference categories. As we determine the dummy variables and the reference categories for each original independent variable, we are going to keep adding the variable names to the respective lists in the 2 spreadsheets. Well, now let's look at the home ownership variable. We can apply the WOE_discrete function to the home ownership variable to calculate weight of evidence right away. We can use the same working data frame. Let df_temp equals WOE_discrete from the df inputs preprocess data frame, the home ownership independent variable, and of course the df targets preprocess data frame. Okay, we have a nice table with weight of evidence for all original categories of the home ownership variable. Now, let's run the plot function on dftemp where our latest results are contained. And here is a graphical illustration of how weights of evidence change by categories. Now let's decide how to organize the categories of the home ownership variable for the final model. Clearly, the categories Other and None are associated with the highest probability of default. While this seems like a breakthrough, it is worth looking into their proportion of the total number of observations in the loan dataset. Fortunately, we already have that information over here. We can see that there are very few loans associated with these categories, less than 0.1% each. Also note that weight of evidence could not be calculated for the home ownership category any, because there is only one observation with this home ownership status. It really doesn't make sense to have dummy variables for these categories. So we don't want to have dummies for them, but we don't want to remove them either, because that would imply losing the information about these customers. In these cases, we combine such underrepresented categories that are similar to them. This is another extremely important pre-processing step. In this lecture, we will be mainly examining weights of evidence and combining categories together. So, let's combine Other, None, and Any with the riskiest category with enough number of observations, that is, the category Rent. Borrowers with category Own have a considerably higher weight of evidence than the ones with category Rent. So these two categories will be in two different dummy variables. Finally, there is the mortgage category. The mortgage category encompasses about half of all borrowers. Hence, it will be in a separate dummy variable. Thus, for the home ownership variable, we'll have one dummy variable for categories rent, other, none, and any, a separate dummy variable for category own, and one dummy variable for category mortgage. We've already created dummy variables for the original categories of all discrete variables in the lecture, where we preprocess the discrete variables. We can easily use them as independent variables for the PD model. The only thing we have left is to combine the dummy variables for rent, other, none, and any. Let's name it home ownership rent other none any. This dummy variable will be equal to 1 if the borrower has any of the four categories and 0 otherwise. Note that we can easily get this by simply summing the four existing dummy variables for each of the categories. We can use the sum method and itemize the four dummy variables we want to sum. Home ownership, rent, home ownership, other, home ownership, none, home ownership, any. Great. We have set 3 dummy variables that will represent home ownership in the PD model. Let's add them to our list with dummy variables. And let's add the newly created dummy home ownership, rent, other, none, any to our list with reference categories. We won't need the 4 separate dummy variables anymore, but there is no need to remove them from the data frame, so let's just keep them there. Okay, great. We've seen 2 of the simpler ways to deal with discrete variables. In the next lecture, we will look into more advanced approaches. Thanks for watching.